Welcome back to another lesson in MTH1W. Today we're looking at defining fractions and equivalent fractions. So in this first activity, it says to place the following fractions on the number line. So here we have fractions 2 over 4, 1 over 8, 3 over 2, negative 7 over 8, 5 over 4, and 1 over 2. And here I'm going to label the tick marks, and I'm going to increase them each by 1/2 or decrease them by 1/2. So we're starting at 0, then we're going to 1/2, then 1, then 3 over 2, and then 2. And here, if we are going backwards, be negative 1 over 2, negative 1, negative 3 over 2, and negative 2. So here, if we look at 2 over 4, 2 over 4 is the same as 1 over 2, gives us a decimal of 0.5, and so here we can write it in the same spot as 1 over 2. When we look at 1 over 8, 1 over 8 gives us an answer of 0.125, and so that will be between 0 and 1/2. Next, we have 3 over 2, which is already represented on the number line, and so we can place that in the same spot as where it's labeled. Next, we have negative 7 over 8. Negative 7 over 8 gives us a decimal of negative 0.875, which would be between negative 1 over 2 and negative 1. Next, we have 5 over 4. 5 over 4 gives us a decimal of 1.25, which is between 1 and 3 over 2. Finally, we have 1 over 2, which again is represented on the number line, which we can write there. So when we define fractions, so fraction is a rational numerical quantity that is not an integer value. So some examples are 1 over 2, 3 over 5, and 7 over 4, and there's other examples as well. A unit fraction is a fraction whose numerator is 1. Remember, numerator represents the top number of a fraction, and denominator represents the bottom number of the fraction. So here, numerator is 1, means that the top number is 1 when there is a unit fraction. Here on the right, there is some diagrams that represent fractions. So for the first picture, we see there's a triangle that is split in half, and half of the triangle is shaded. And so we'd say that the shaded area is 1 out of 2, or 1/2 of the triangle. So when we're simplifying fractions, we can simplify a fraction by canceling out common factors in the numerator and denominator. When a fraction is written as a rational number with the smallest possible denominator, we say that it is in lowest terms. So a note here that factors are numbers that multiply to give the original number. So an example, 2 and 3 are factors of 6 because we see that 2 times 3 would equal to 6. So here it's telling us to simplify 7 over 21. And so if we divide by greatest common factor, or GCF here, we see that we can divide both 7 by 7 and 21 by 7. And so 7 divided by 7 will give us 1, and 21 divided by 7 will give us 3. And so here we get an answer of 1 over 3. Another way to look at this is if we have a number which is 7, we can multiply that by 1, and that same number, we can multiply that by 3 to get to the answer 7 over 21. And here, so we can cancel out the values of 7, which is equal to 1 over 3. The next question here is we have negative 2 over 4. And our greatest common factor here, again, we can divide both 2 by 2 and 4 by 2. And we get an answer that is equal to negative 1 over 2, because 2 divided by 2 is 1, and 4 divided by 2 is 2, and we still have the negative value. Again, just a note here, you never want to leave the negative in the denominator. So either we write it beside the fraction or we write it in the numerator. What we don't want to do is we want to write our answer as 1 over negative 2. And so here again, the division line of fractions behaves like a set of brackets. This means that the numerator and denominator must be found before doing the division. If we think of the order of operations, again, we will do brackets first and then division comes later. And so here we have 3 minus 9 over 2 squared plus 4. And so here we can rewrite it with the brackets. So 3 minus 9, that's the numerator. In the bottom, we have 2 squared plus 4. So again, we're going to solve for the numerator, solve for the denominator, and then we divide. And so here we have 3 minus 9, which is going to be equal to negative 6. And 2 squared, remember 2 squared would just represent 2 times 2. And we're going to add that by 4. So here we have negative 6 divided by 2 times 2, which is 4. 4 plus 4 would give us 8. So here we have negative 6 over 8. And anytime we have an expression, we always want to see if we can simplify. And here we can simplify by dividing both 6 by 2 and 8 by 2. So here our final answer will be negative 3 over 4. Here, the next question, we have 4 times 5 divided by 7 minus 9. 4 times 5 is equal to 20. 7 minus 9 will give us negative 2. Here we can divide both 20 by 2 and 2 by 2. Still have that negative there. 20 divided by 2 is 10. And 2 divided by 2 is 1. And here we don't write over 1. And so we simply just write the number in the numerator, and so our answer here will just be negative 10. When we look at equivalent fractions are two fractions are equal or equivalent if they can be written in the same lowest terms. We can convert a fraction to an equivalent fraction by multiplying or dividing both the numerator and the denominator by the same non-zero number. So here, just a tip. Again, what you do to the top, which is the numerator, you must do to the bottom, which is the denominator. To remain equal. And vice versa. So again, if you do something to the denominator, you must do to the numerator. If you do something to the numerator, you must do to the denominator. And so here it says express 3 over 4 with the denominator of 32. And so here our denominator is currently 4. To get to denominator of 32, we must multiply both the bottom by 8 and the top by 8. So again, what you do to the top, you must do to the bottom. Whatever you do to the bottom, you must do to the top. So 3 times 8 will give us 24. And 4 times 8 will give us 32. So what we would say is 3 over 4 is equivalent to 24 over 32. Here, the second question is 25 over 45 with numerator 5. So here we have 25 over 45, and we want to get a numerator of 5. So we need to divide the top by 5 and the bottom by 5. And so 25 divided by 5 will give us our numerator of 5, and then 45 divided by 5 will give us denominator of 9, so 5 over 9. So here we can say that 25 over 45 is equivalent to 5 over 9. And so here when we look at ways to express fractions, there's 3 main ways to express fractions. So proper fractions. So proper fractions are a fraction where the numerator is smaller than the denominator. So an example is 4 over 5. An improper fraction is a fraction where the numerator is larger than the denominator. So an example, negative 12 over 5. And then mixed numbers are numbers which include an integer and a proper fraction. So an example would be negative 2 and 2 over 5. And a note here, in math, the preferred form is almost always as a proper or improper fraction rather than a mixed fraction. And so here we see that we have a mixed fraction. We have 2 and 2 over 5. And so the first step here is to take that integer value that's in the front and multiply that by the denominator. So the first step here is to multiply the integer value with the denominator. So we're going to multiply the integer with the denominator. And the second step here will then be to add the value calculated from multiplying the integer and the denominator and add that with the numerator. So here we're going to add the value calculated with the numerator. And so here, if we write that out, we have 2 times 5 plus 2. And here we're going to keep the value in the denominator. So that's our next step. So we're going to write the improper fraction by keeping the denominator the same. So we can fully calculate this. So 2 times 5 will give us 10. 10 plus 2 is 12. And we keep the denominator the same as 5. And so here, when we convert 2 and 2 over 5 into an improper fraction, it will give us 12 over 5. If we're looking at the opposite direction, so we're going from improper to mixed, the first thing we want to do is we want to find how many times the denominator goes into the numerator. and that will give us our integer value. So this is our integer value. So here, if we look at this, you see that 5 goes into 12 two times. And the second step we want to do here is we want to find out what's left over. And so here, if we take 5 and 5 from there, we're left with 2 over 5. And then finally, the third step is to write the mixed fraction. So our integer value here is 2. 5 goes into 12 two times, and what's left over is 2 over 5. And here we're going to finally look at comparing fractions. And so to compare fractions, we first convert them to equal fractions with a common denominator. This denominator is called the lowest common denominator, or LCD. So here, remember, these symbols represent less than, greater than, and equal. So here we have 4 over 5 and 7 over 9. And so the lowest common denominator between 5 and 9 will be 45. And so remember, whatever we do to the bottom, we must do the top. So here, if we want to make the denominator 45, we need to multiply both the top by 9 and the bottom by 9. And so here, 4 times 9 will give us 36, and 5 times 9 will give us our lowest common denominator of 45. And here we have 7 over 9. To get it to the lowest common denominator of 45, we must multiply the top by 5 and the bottom by 5. 7 times 5 will give us 35, and 9 times 5 will give us the lowest common denominator of 35. And so here what we see is that the denominators are the same, so we can just compare the numerators. We see that 36 is greater than 35, so that means, therefore, 4 over 5 is greater than 7 over 9. Here we have 3 over 7 and 2 over 5. We see our lowest common denominator between 7 and 5 is going to be 35. And so here, if we have 3 over 7, to get to the lowest common denominator of 35, we're going to have to multiply the top by 5 and the bottom by 5. 3 times 5 will give us 15. 7 times 5 will give us our lowest common denominator of 35. Then we have 2 over 5. To get to our lowest common denominator of 35, we need to multiply the top by 7 and the bottom by 7. 2 times 7 will give us 14, and 5 times 7 will give us our lowest common denominator of 35. So here we see that 15 is going to be greater than 14, which means that 3 over 7 is going to be greater than 2 over 5.